Welcome friends. In this session we are going to discuss about the DR analysis of REL670 distance protection relay using Sigra software. In the last three sessions we have already discussed about the basics of Sigra software. We have discussed about the DR analysis of 7SA522, which is the Siemens distance protection relay using Sigra software. We have also discussed how to determine the fault location using Sigra software if you have a DR available with you. We have also discussed how to analyze the MICOM P444 or P442 relay DR using Sigra software. And as promised, in today's session, we are going to discuss about the REL670 relay DR using Sigra software. So, without wasting any time, let us start with today's topic. And as you can see on your screen, I have a folder in which many DR is available, and I am going to discuss about one or two REL670 relay DR, and these DR are the actual system tripping DR which are available with me, and these are very old DR, but I am going to discuss these DR for the better conceptual clarity only, and I am not going to discuss in details about the analog channels and how the faults are determined, because these are already covered in last 2 or 3 sessions. So today we are going to discuss in details about the digital channels of REL670 relay and how to analyze the REL670 relay DR. So now let us start. First of all, I am going to open this REL670 relay DR, and this I will for the time being keep as no. And as you can see, this DR is presently open and in this RMS value format. So let us select as instantaneous, and this is in the secondary format. And if you see here, the sampling frequency is 1000 Hertz, which is same as for Siemens relay. In Siemens relay also the sampling frequency is 1000 Hertz or 20 samples per cycle for a 50 Hertz system. Now, another important thing, if you see here, there are many comments written, and these are basically related with REL670, and this is available to you because of these file, which is HDR or called header file. In this REL670 relay, if you save the DR, you will by default get 3 different files. One is CFG, that is COMTRADE file, then DAT, that is data file, and HDR, that is header file. If you remember that from the last session, then in the MICOM relay, you will have only 2 files, which is CFG and DAT. In Ciprotech relay, you will have many files, but the 2 common files are CFG and DAT file, which is common in all the relays, be it REL670, MICOM P444, P442, 7SA522, D60 or SCL421. In any relay you will get CFG and DAT file, and apart from that you will get some relay specific files, for example HDR file in REL670, which is the header file, then DG for Rio, etc for 7SA522. So now since I have selected this in the primary terms, not primary, presented is secondary, just selected as primary. Now all thing is in the kiloampere range, and if you see here, before the fault inception, the system is running normally with normal load current flowing in all 3 phases, that is R phase, Y phase, B phase, and there is no or practically no current in the neutral. The 3 phases voltages with respect to ground are also within permissible limit, and in the ideal range there is 765 by root 3 for a 765 kV system. Now at this particular point of time, a spike in R phase current is noticed, and since no other current is observed in Y phase and B phase, that means this is a fault which involves only R phase, and this same current is reflected in neutral also. That means this is a fault from R phase to ground. And if you see here, at the point when you see increase in R phase current, there is a dip in R phase voltage, which confirms that this is an R phase to ground fault. Now if you move just below, you see here there are many digital signals. First we will discuss about the meaning of these digital signals, then we will discuss how this relay behaves. So if you see here, this trip is basically the general trip from REL670. R phase, Y phase, B phase tripping is the general tripping of R phase, Y phase, B phase for any protection function which is issued by REL670 broken conductor. Then this ZM01 STRT and trip is basically ZM01 means zone 1, trip and start. Similarly, zone 2 trip start, zone 3 trip start, zone 4 trip start, and zone 4 trip start. Then you have SOTF trip, then ZCOM, which is carrier added trip, which is basically your zone 2 plus carrier receive. Then you will have ZCOM multi-phase trip. After that, you will have this signal, which is DRB02 input 20. This is because of incorrect application configuration, incorrect configuration in DR, and maybe during the application configuration stage, the signal name has missed and someone has not written this signal name, and that's why it is coming as DRB02 input 20. We will discuss about this application configuration in the coming sessions when we discuss about the REL670 relay configuration. Then you have this ZCAL IREVBL. This is the REL's specific signal, and this signal means this is basically the communication added tripping cases, and in this is the current reversal guard. And if you remember from our theoretical session, in that theoretical session I have already discussed, if there is a parallel line with POTT scheme, then in that case you have to enable a current reversal guard for 60 to 80 millisecond, and that current reversal guard signal is ZCAL iReverseBL. And if you have any doubt regarding this, please go through the playlist and watch the session on carrier added protection, and in that session I have explained in detail about this current reversal guard. Now if you see the below 4 signals, which is PHS STFWL1, this is basically the phase selection started forward. L1 means R phase, then phase selection started forward, Y phase, B phase, and ground. Then PSP, which is power swing operated. I have already explained about the concepts of power swing in one of the session. Then BCU unhealthy is the digital signals which is may be hardwired to this relay. Then BFR operated is basically the breaker failure relay operated or LVB protection operated. I am going to discuss about this breaker failure in our coming theoretical session. AR unsuccessful, then breaker failure trip 2. Basically this LVB or breaker failure, you will have two timers. One is T1, that is trip repeat, and then T2, which is the back trip or the final trip. Stub release for 1.5 breaker scheme, I have already explained this, what is the stub function. Then the 6 breaker phase status, that is tie CB open R phase, Y phase, B phase, main CB open R phase, Y phase, B phase. Then carrier receive, carrier channel fail, DT trip receive. TUV trip means under voltage trip. DT send channel 2 AR operated, 21.1 operated, then protection trip, and then finally carrier send. The two signals, they are block 5 input 72 input 73. This is again due to the mistakes in application configuration. This signal name is not coming correctly. Now if you see this DR, at the point when the fault is detected by the relay directly issues trip command. The first signal which is getting activated is tripping command, and why this is getting activated is probably due to the fault is now in the zone 1. And if you see here the fault, if you see here zone 1 start, and immediately relay issues zone 1 trip command. Why? Because zone 1 is instantaneous. So once relay detects a fault in zone 1, it will issue a trip command immediately. If you see, if the fault is in zone 1, so zone 2 will also pick up and zone 3 will also pick up, because suppose if zone 2 reach setting is 10 ohm, zone 2 20, zone 3 30, and if a fault is at 5 ohm, so 5 is definitely less than 20, less than 30, and less than 10. So if the fault is in zone 1, then zone 2 and zone 3 will also pick up. So relay sees the fault in zone 1, it issues a trip command, and which phase it will trip, because it has seen that the phase selection is started in R phase, so it will issue a trip command to R phase only. If you see here, relay issues the trip command to R phase. Once relay issues trip command to R phase, your R phase breaker should open. So R phase tie CB opens here. This is your R phase tie CB, and at the same time R phase main CB also opens. This slight difference is because of maybe the timing difference of the two circuit breakers, or because of the auxiliary contact time difference. But practically, if you see, both circuit breakers opens at the same time, and since the fault is in zone 1, so relay has also sent the carrier signal to remote end. If you see here, relay has sent the carrier signal immediately with zone 1 start or zone 1 trip, because it is the same thing. So relay has sent the carrier signal, and it doesn't matter whether it is a POTT or POTT scheme, because in both cases, if their fault is in zone 1, relay will send the carrier signal. So now the important thing is the breaker opens here, and now after almost 1 second, if you see the time delay, which is almost 1 second, your circuit breaker closes. So main circuit breaker once closes, voltage will come again build up, and also the current will start flowing from R phase, Y phase, B phase, and neutral current should vanish. So now you see here, neutral current is 0. Ideally, all three phase current is coming, neutral current is 0, and power flow started. After the closing of main breaker, tie breaker should close after the priority time delay of suppose 1 second. So if you see here, after closing of main circuit breaker, the tie circuit breaker closes almost after 1 second. So this is called the priority closing, and this priority closing is applicable for 1.5 CV scheme. In 1.5 CV scheme, both circuit breaker, main and tie circuit breaker, opens immediately after the relay issues trip command. But the first circuit breaker closes at suppose a dead time of 1 second, and the second or the tie circuit breaker will close after the dead time of suppose 2 seconds. It should be more than the dead time of main circuit breaker, and the second circuit breaker closes at the time of 2 seconds. And if your main circuit breaker is in the open condition before the inception of fault, then tie circuit breaker will close at 1 second only. So this is called the priority auto closure. We will discuss it in details in our coming sessions. So in this session, we have seen how to analyze the REL670 relay DR, and now I will show you that circle diagram. You will have nothing at present because I have not configured the channel. So go to network configuration and then select this IL1, that is R phase, Y phase, B phase current, and then neutral current properly. And if you select these things, now you can see over here that your city ratio is coming automatically. Again, select this R phase, Y phase, B phase voltages over here, and your CVT ratio will also come. Now click OK. Your characteristic the zone the characteristics of how the fault is moving, it will come, but you cannot get the zone reach boundaries because, as I have already explained in the last session also, because we don't have the REO file available with REL670 relay, so we cannot have that zone boundaries. We can use the Ciprotec relay zone boundary, but that is not advisable because the settings of Ciprotec and REL is very different. You cannot conclude anything with the Ciprotec relay zone boundary by using the characteristic of REL670 relay. So now I will keep up to this point only. In this session, we have discussed how to analyze the REL670 relay DR using Sigra software. In the coming session, we will discuss about the DR analysis of differential and REF relay, and also the busbar protection relay if the DR is available with me. And thereafter, we will move to some theoretical sessions. So hopefully whatever is explained in this session is clear to you. If you like the video, then please share the video with your friends so that more and more people gets aware about these contents, more and more people gets aware about these concepts also, and they can implement in their organization, in their workplace. If you have any problem with this content, then also you can comment in the comment section, so we can improve from our next session onward based upon the feedback received from your side. So thank you for watching this session. We will meet again with some new topic. Till then, thank you and goodbye.